The final judgment of choosing cell rating would be based on the severity and frequency we have analyzed. So let's plot a risk reduction matrix showing severity against frequency. We have already seen how we can determine the frequency and the severity of the consequence. Now it's time to check if we need to reduce the risk more or if the protection we are already considering here is enough. Here comes the risk reduction factor. So, based on this matrix, we can determine the risk reduction factor. Our target is to reach a risk reduction factor that is equal to 0. Otherwise, we shall need to add more protection in order to reach 0. So, for example, if we calculated the frequency of the event per year to be 0.01 while we are having a major consequence, then in this case, the risk reduction factor is 2. This means we must add protection layers to our system. So if this is a Ceph function that does some action at high pressure and its cell rating is 1, for example, then in order to reach a risk reduction factor of 0, we shall need to increase the cell rating of this function to cell 3, reducing its frequency to the minimum. Or we can add a PSV with a probability of failure on demand of 0.01. This shall also reduce the frequency to 0.0001, leading to a risk reduction factor of 0. Or if we want to reduce the severity of the consequence, we may add very strict measures. For example, if the issue is related to fatality, we can consider it as a very restricted area. Thereby, we can reduce the risk reduction factor through this direction, and this shall make the consequence severe or minor instead of major. Or we can combine both approaches by reducing severity and frequency. This may be the approach in systems where we need many risk reduction measures and we cannot afford a high cell rating, or when installing PSV is not applicable.